Okay, now we start the first chapter of the calculus. Calculus is the mathematical foundation for much of university mathematics, science, and engineering curriculum. Okay, it is the first exposure to rigorous mathematics to the college freshmen. Okay. Calculus is an introduction to the modeling and approximation technique, and it is also a language to explain the nature of the world. In this first semester, we start with the differential and integral calculus on functions of single variables. In the second semester, we will deal with the vector calculus and multivariable calculus. Okay, so we will concentrate the differential and integral calculus on functions of single variables in this semester. Okay, many of recent calculus texts are using computer algebra system. We have adopted a wonderful free and open source program, Sage. It works well with Firefox or Chrome instead of Internet Explorer. Okay. This system language for Sage is Python, which is a powerful mainstream computer programming language now. MIT have taught the C++ for many years for all students as a mandatory course. But now they do not teach it anymore. They now only teach Python languages. Okay. These Sage are using Python languages. Okay. Most of the content that you're going to see and use will be found in this website. Okay. This is a textbook that we're going to use. Okay. Calculus with Sage. By me and with some co-authors. Okay. But also you can use other calculus textbook because most of the contents are similar. But you may have to choose the problems. But exercise problems comes from this textbook to be shared. Okay. Okay. First chapter is on functions. The first section is on functions and its graph, and symmetry, and common functions, and translation, stretching, and rotations of function, and a few basic concepts were added on it. Okay. Here, participation, so this is evaluation will be based on. I think I made it a little differently, but I think I may keep this guideline, which was made with a deep consideration for the nature of our class. Your participation will be counted as 20%, and homework will be 20%, and midterm exam 20%. And final comprehensive examination will be counted as 20%. And your activities and presentation 10%, and all others will be counted on 10%. So it will make 100%. That gives you a grade on it. So I will give more emphasis on learning process instead of the exams only. Okay. Okay, here is the basic notations that we're going to use. This notation says means implication. So if this means imply, that means if then is when. So if A is true, then B is true. In that case, we use this notation instead of writing a whole English word. So the right-hand side implies, left-hand side implies left-hand side, right-hand side, and if right-hand side implies left-hand side, then we write in this way. That means if and only if. If this is A is true, then B is true. Also, if B is true, then A is true. Then we write this notation, if and only if. This one. This, you know what this means. This is set membership. This is a subset notation. And therefore, and because. And this is existential quantification. There exists X that satisfies such a thing. So then I will use this E instead of there exists. Okay? I will use this notation. A, the flip of A, is for all, or for any, or for each. Okay? So for all X, P of X means P of X is true for all X. It means all X. That's what it means. So we will use this notation. So it will make a lot of logical sentences in a very simplified form. Okay. Okay. The textbook here. The textbook is composed in this way. The axiom will be given, and then definition will be made from that axiom. Then theorem will be developed. Then you will see examples and exercise and problems like this. That's the basic structure of the textbook. Okay. There are many computational tools available now, but depend on the majors that you are having. The basic standard softwares are different. In some major they are using Maple. In some major they are only use MATLAB, and the other department are using Mathematica. So there are many diversity of softwares. But Java is the one which is kind of popular. So that you can just use it on the web. If you are connected through the internet, then you can use it for free. So we have developed some of the Java tools which you can find from web addresses here and there. Mm-hmm. And then Maple is a software which was made from Canada, and I have used it a couple of years. And MATLAB is the most popular software for engineering students, particularly who's doing research and in the business world of engineering side, this is a basic standard. MATLAB means matrix laboratory. It's an abbreviation of matrix laboratory, MATLAB, which has many features. Mathematica is the most popular software in these days. And Wolfram Alpha is what I show you. Here, if you go to this web address, then there are all the branches, calculus, number theory, and linear algebra, engineering mathematics, advanced calculus, etc. There are many, all math subjects are given, and this basic command were introduced in here. So you can, if you have a short question on the web, then you will find the quick answer from here by just making an order to get. Okay. So, for example, if you go to here for the calculus side here, then here, calculation analysis here. So to do integral, if you just click it, then integral x squared sine x squared, you find the solutions here. Mm-hmm. Here, this is the solution of this one. This is the meaning of it, and this area underneath of this. And if you go further, for the minus 20, the nature of this function is like this. And derivatives and limit, you can always find anything. Yeah, for if it is a very short problem. So you didn't have to spend a whole lot of time in high school years to find the limit of such a function. If you know the concept, you don't. For example, if you make some difference here. If you find the time n here, then what happens, you see? Then, if you make a square of it, okay, even you make it very two, if you have this kind. So, if you know how it works, then the same techniques can be applied for that formula to get the answers. That's why this programming was made, to deal with it. So what you have to know is the concept and basic technique to deal with such a thing. All other things are use those algorithms to solve the complex problems. That's the way that has been developed. Mm-hmm. In earlier years, there was no way to do it, but nowadays there are very popular tools: sequence and sums, and limit, and product and series expansions and coordinate geometry, differential equation, complex analysis, vector analysis, and numerical analysis. There are whole Newton's method. Let's see. Solve this. Who can solve this by hand? It's usually for the real world problems. The solutions are not exactly 2 or 3 or -1. It's always at some point. It could be irrational numbers. It may not be exact numbers. Okay. So in that case, all you have to do is find the approximation. But you cannot find that approximation by hand. But with the aid of the tools, we were able to find the real approximation with the meaning of it like this. And you can always make a change. But this has a limit. You have to see the advertisement, and also you cannot use the complex command. This is only one-line command is available. But now the problems that we are dealing cannot be done in one line. So this is not the real answer for real world. But for the classroom use and at the elementary level, this works fairly well. That's why many other countries are using it in a proper way in the process of learning calculus. We have developed the more general tool that can handle the most of the problems that you're going to face, and that we are going to deal with. This is what we have found. For example, in here, if we do the double integrals, multivariable functions. For example, if we wanted to find the multivariable calculus, let's see the partial derivatives and multiple integrals and volume integral. Let's see. For example, if you want to find the triple integral of this, then the solution is 128. We can find it, but by hand also. But if we have if you use this tool, then we can easily have the solutions. If we have different functions like this, then we can also find the solution for that. So what we need now is not the solution. We need to know how it works. We should know the concept first. So our exam problems will be based on to check whether you understand it. The concept of those computations, and I will ask you whether I'll check whether you can really solve the problems or not. Okay. Mm-hmm. So, but if you have done it and you know it, then you will be able to answer it. But if you don't try to do it, then you may have a hard time to give the right answer. Mm-hmm. Okay. So this is a web address in United States. Then we were able to make our version of the server at our university in Korean language, so you will be free to use it. Okay, but and here, yeah, you can make your. I will make one ID and password for all of you for our particular class to share the web page together to share the learning process. So we will use one ID and password together. I will let you know in this website. Okay, this is how it works. I will show you. Okay, first, but those are the the kind of information that above what we supposed to cover. Okay, now calculus. First semester on single variable. Okay. Chapter 1, functions. Chapter 2, limit and continuity. And chapter 3, theory of differentiation. I think most of you are very familiar with this. Yeah. With the college entrance examination, you have covered these 3 chapters quite thoroughly. And these integrals and some application of integrations, that's what you have learned in high school years in Korea. But now, you're going to see some more applications and as well as the complex functions that you haven't learned in high school years. And here, parametric equation and polar coordinate and infinite series and infinite series. So this is what we're gonna cover in the first chapter. So we will cover the first 10 chapters in this semester. In the fourth semester, we will deal with the multivariate calculus. I will start with some examples. This is the kind of example that you have seen. Yeah, for the sine, this is for the sine x. Yeah, you know how the area of this one. But if you have the k in here, then the values will be buried as k varies. Okay, so how we can deal with it? That can be done in here. Okay, this is function, then sine x. If k is 1, then this is the area. Okay, this is the area from pi here, from 0 to pi. Okay, but if we make k5, then we have this kind of graph, and the area in between is going to be this one. If we move this, then we will have such a variation. These are the things that I have. Only these 5 line command give us all these kind of features. Here, I defined as a variable k and x, then the sine k of x was given here, and the slider was made, and then integral of 2 pi sine kx square root of, this is the function, the area, the equation to find the area underneath that makes it. Okay, such things. So we will go through how to find the integral from 0 to pi of sine x dx by hand. You will have such an exam problem in your midterm, but your homeworks may have a little further than like this. You may change the you may if we change this one as a cosine. Then let's see how it happens. Then let's see what it happens. This doesn't make any change. So if we make a cosine here, then let's see how it's gonna do. Cosine here, and graph, plot cosine, and show ratio maximum. Let's see how it goes. Oh, here it should be cosine. Yeah. Let's see. This should be cosine. Here, you see, if you make by small changes, if you understand what's the formula of finding the area underneath of the graph, then you will find this. This makes. You can also find for any other functions like this instead of trigonometric functions. So that's the things that we're gonna do after we learn a basic concept. I will show you how to deal with the more complex problems. Then you will do practice. And then you will make your own problems to show others. Okay? Okay, here, yeah, this is a parametric plot of what? Of the graph. If we wanna have, if we have a different, instead of 4 pi, if we have a 3 pi here, then let's see. Then we have different functions like this. This is a parametric plot. Okay, and so the book that you have has a lot of web address and QR code in it. So you don't have to do all the work. You understand it. If you don't understand it, then you do simulate it. And to understand the meaning of those computations you have done during the high school years. At least for the earlier chapters, you already know. And for this is section 11. Section 11, here, okay, something else, and what? Okay. Those are the preview of some features the textbook has. Here is the section 1.1, History of Calculus. Okay. The growth of mathematics parallels the development of human civilization. Okay. This is the real start of our class. Okay. Is there any question before we start the section 1.1? Okay. Function and its graph. Okay, then let's keep going. Calculus is one of the branches of the mathematics focused on functions, series, limits, derivatives, integrals, and their relations. Okay. Before we go, if someone who has a curiosity, what the effect of the growth of mathematics affected the development of our life, you may go this web address. Okay, here, if you go, then this website shows all the lectures that I have given at 성균관대 University last year. And it says, what? How the development of mathematics affected the change of the development of world history. You may go there to understand what I say now here. Okay, so you may go back, you may look over this part, the mathematics of movement, which is the start of the calculus. So then you will understand what I mean. Okay? Okay, now function. You know the meaning of function. Function is a mapping which has such a condition, which is for each element x in a given set D, a function f assigns exactly one element known as f of x. For one x value, the f of x should have exactly 1, not 2. So this is not the example of a function, because for a given x value, it has a 2 point. So this is not a function. Okay, you know it well. And in this, now we learn the piecewise defined function. A function defined by different formula in a different part of this domain is known as a piecewise defined function. So it has the function, the shape of function is different here, and the shape of function is different like this. That's a piecewise defined function. 그러니까 구간별로 다르게 정의된 함수들이 합쳐져 있어서 전체 구간에서 정의된 함수를 piecewise defined function이라고 해요. Let's see the example. This is an example of a piecewise defined function. It has this value in a negative domain. It has this shape on this domain, and this is a straight line at after x value over 2, something like this. Is a piecewise consistent function. If you go to this website, then you know how to draw the graph of it. Okay, here's symmetry. And this is the shape of the graph which has symmetry with respect to the x-axis. You see? This is a symmetry with respect to y-axis. This is a symmetry with respect to the origin. Okay? This is if you have a graph then you can find some kind of similarity from the graph of those functions. Okay, this is the example of piecewise. Okay, this is okay. This is another example on the symmetries. This is a symmetry on y-axis. But as you see, if f of x is same as f of minus f of x, then f of minus x is equal to minus f of x. Then we call it is an even function, like this. If it is like f of x is the same as minus f of minus x, then we call it is an odd function. This is sine x is an example of an odd function, and cosine x is an example of even function. Okay, and this is the y equals sine x plus cosine x. This is not an example of even or odd functions. Okay, this f of the sine x plus cosine x is neither even or no odd function. Okay, yeah, you can. This is a decreasing this function decreasing on this domain and increasing on this domain. This function increases in whole domains. Okay, and these are the example, the exercise problems that you're gonna deal with. Okay, this is just simple. Draw the graph. Before you draw it by hand, you know how to draw it. Okay, then you can do it. But as it getting complicated, then you may have a hard time to draw it. So the best way is you understand how to draw the graph of the function, and then use it to deal with the complex functions. That's the way. Okay. Anyway, yeah, there are several functions here. I may. Okay. Yeah, this is an example of neither odd or even functions. And so there are typical problems that you already know. See, section 1.3, the common functions, the popular functions they have known. Linear functions, you know it. Y is equal to ax plus b, or mx plus b. Polynomials, this is a typical function. And power functions like x to the a, the y equal x square, x cube, x to the fourth, x to the fifth, and also, yeah, f of x. Then this is some square root of x and log x, and then y equal x, 1 over x. This is a reciprocal function, and what? And this is relational functions. The denominator and numerators are all both polynomial functions. Then we call it is a rational functions. This is an example of a rational function. And algebraic function. Algebraic function. You should know this well. Algebraic. You should understand this meaning. Algebraic. This will be used over and over again. Algebraic function is a function constructed using the algebraic operations such as addition, subtraction, multiplication, division, and taking root. So like this. This is a polynomial, and you took a square root. Then this is one example of algebraic functions. The graph of this can be drawn in this way. And this, and also trigonometric function and periodic functions. And this is trigonometric function, sine function and cosine. These are the example of trigonometric function, and these are the periodic function. These are periodic. Yeah, you know, the same patterns appeared with a certain period. We call this is the periodic function. So this is a trigonometric function with the period. So it's a periodic function as well as a trigonometric function. Okay, and also exponential function, a to the x. Okay, if a is bigger than 1, then it shapes like this. A is between 0 and 1, then it shapes like this. Okay, and logarithmic function, like log a to x. Then this means x is equal to a to y. So it's an inverse function of exponential function, logarithmic function. So you can draw the graph in this way, depend on the base, 2, 5, 10. And the last section is translation. Translation, stretching, and rotation. Here, we can easily draw the function of 3 cosine plus sine x2 and four different functions here. Here, this is f of x, this is fx plus 1, f of x minus 1, f of x minus 1, f of x plus 1. You see, this basic function is the blue. Then if you add 1, it goes up to the red. It subtract minus 1, then it goes down to here. If you change the value, the variable to x minus 1 instead of x, then it moves to like this. So you will see, we can draw all the many graphs together in once, like this. Okay, and what else? Reflection. This is the example. This is example, and the graph cosine x squared plus e to the minus x graph is given as a blue. Then if minus f of x comes like this, and f of minus x is like this, as a green, something like that. If you change the graph, if you make it sine here, then you will have a totally different graph, like this. Okay, so you can make any function here to draw the graph on the homework problems. We do the same. Okay. Next. So this is so whatever you so you know how before you when you wanted to draw the graph, you have to find the first derivative, and then you have to solve the equation to find the critical point, and then you need the second derivative, and to find the inflection point to point out it and find the value to draw the graph of it. But now, actually, you can draw the graph first and find the similarities and things. That makes some changes at university. And vertical and horizontal stretchings here. And vertical stretch vertically and horizontally. F of c, suppose y of x is a given function with c positive number. Then y equals c of f of x may make it it stretches. If c is small, then it's compressed. Okay, so that's what it means. It's stretchy and compressed. And what else? So for example, if you have such a function, then that makes the bottom one come up to top. And some more of translation. And so actually, with those simulations, you understand the relationship between the functions, like this. So yeah, we have found the kind of relationship like this from the lots of simulations that we have seen. Okay, and the proof of this is easy, as you have learned from the high school years. Okay. And these are the examples. Okay, so the example shows if you have such a functions, then find f plus g of f minus g of product of two functions of the ratio of the two functions, and you know how to do it. And this is composite functions that you see. So also, not only find it, also you can draw the graph. This is a sine function, then this is a sine 2x. Okay. Or 2 sine x. Okay, here, the exercise of chapter 1 that you can find from this web address. Here, these are the things that you are supposed to do in a week. I ask you to solve only one problem. Each of you solve only one problem. Choose one from this. Okay? And solve it. And upload your solution in Q&A. And you find some interesting problems, then you may revise other solution. At least one. To make a better solution. Okay, that will be your homeworks. Okay? Okay, so all you have to do is just choose a problem from these four sections and upload your solutions in this format. Okay? This is the way that you're supposed to do. Okay, if we go there, for example, you will find some of this. For example, here, if you solve a problem in chapter 1, okay, make a page number here and exercise 1.2 and number 3, for example, the problem. Then solved by your name and problem number and your solutions like this. Then upload it. That's all you have to do. And after you go to other solution and take a look. If you think it is a perfect answer, then you just finalize it by your name. Then that's done. Then I will start to grade it. Okay. So after then I will give you a final okay to you. Then the number that you got this final okay by me is what the credit that you get. The first one, the first revised one, and final, the final one, the one who finalized it. Okay, it's something like this. I will upload the problem files, even though you can just drag it from the website. Okay, solved by someone and revised by, then finalized by. Then these 3 persons will get the same credit on this problem. Okay? I think that will do it. Do you have any questions? Then we will meet on next Wednesday, and we will cover chapter 2.